I thought I was late. And, maybe you felt it too. You sit down at your desk and you've literally got 50 browser tabs open, courses everywhere, AI news feeds, machine learning videos, career advice. It's just endless. Everyone else seems ahead. Everyone seems so confident, like they just understand it all. And somehow, you don't. It's complete information overload. And then, there's just silence.
But what if the problem just isn't you? What if nobody actually gave you the map? You see, beginners often feel lost, not because they are incapable, but because they were handed fragments. A little Python here, a little machine learning there, a whole lot of agent hype, and then they were just told to run.
Welcome to this explainer on the data science super agent. We're going to take a cinematic journey exploring one really timeless question. How does a human become a builder? We'll move step by step from that initial confusion all the way to real-world judgment. And that journey begins with one foundational truth. Start from what is true and build from there. The foundation of all real work is starting with true business problems. You see, a model is not the problem. An AI agent is not the problem. A decision is the problem. We start with reality, not the hype. Part 1. The map to reality. Traces of the real world.
Right, but if we don't start with opening a dataset and training a model, where do we actually begin?
We begin by understanding the evidence. Think about it. On one hand, you have the actual event in reality. Say, a customer buys a product on a rainy Thursday. But on the other hand, you have the data, which is just a selective row in a database. Data is not reality itself. It is merely a trace of it. It's incredibly useful, for sure, but it's also entirely incomplete. And that leads us to our first core principle. Data is structured memory. We store data because at scale, human memory alone just isn't enough to run a system. We use this structured memory not to find some perfect truth, but to support better human judgment. Part 2. Reasoning under uncertainty. Honest thinking.
Okay, but the real world is incredibly messy. It's totally unpredictable. Weather changes, markets shift, people behave in weird, unexpected ways. Reality rarely fits neatly into rows and columns, does it?
Exactly. The world doesn't become perfectly knowable just because we put it in a chart. And that is exactly where probability comes in. Probability isn't about demanding absolute certainty. It's about measuring likelihood. It's literally the language of doubt. Mathematics allows us to reason about uncertain outcomes without pretending we have perfect knowledge. Which brings us to our next truth. Uncertainty is not ignorance. It's actually a structured, honest way of thinking. Simple answers should be simple for the right reason, not because we just decided to ignore the uncertainty in the room. Part 3. Learning through feedback. The discipline of models.
All right, so if the world is uncertain, and data is just a trace of that messy world, how do machines actually start finding patterns in all this structured memory?
We break machine learning down into a strict discipline. It's not magic. Step 1, you name the target. Step 2, you build features that represent reality. Step 3, you establish a simple baseline just to keep us honest. And Step 4, rigorous evaluation. Machine learning is simply a disciplined adjustment measured against simple baselines. This means learning is simply improvement through feedback. A model is not allowed to be arrogant. It doesn't get trusted just because it exists. It absolutely must earn that trust through continuous evaluation on data it hasn't seen before. Part 4. The architecture of AI. Modern AI from first principles.
Okay, I can grasp standard machine learning, but what about modern AI? You know, large language models, deep learning, generative AI. Don't they break all these rules? Aren't they basically acting like black box magic?
They definitely feel like magic, but they are really just an evolution of the exact same first principles. We start at the base with embeddings, which is just representing meaning as mathematical distance. Then we move up to attention, literally teaching the machine what context to look at. And at the peak, we have transformers and agents. So, AI isn't magic?
No.
It's layers. It's just layers of adjustable transformations, feedback, and context. Generative models and super agents are just an architecture designed to represent the world well enough to support reasoning. And that's the ultimate takeaway here. AI is structured learning. Once you understand the layers, how evidence enters, how representations shape it, and how tools act on it, you strip away the fear. You stop worshiping the machine and you start directing it.
Part 5. Beyond the demo, shipping real intelligence.
Okay, let's say I've built the layers. The AI agent is working perfectly on my local machine. It's giving these great answers. I'm ready to ship it into the real world, right?
Not quite. It's so easy to get an amazing standing ovation demo on your laptop, but reality is full of broken pipelines, shifting data, and user complaints. A demo only proves an idea can work once. A real system must prove it can keep working safely when the real world inevitably changes. To ship real intelligence, we have to embrace the unglamorous but absolutely vital reality of ML ops. You must track data drift, like an AI suddenly failing because it was trained on summer data and a winter storm hits. You have to monitor data freshness. You need to implement human review, and you must put guardrails on actions. A model used in the real world needs boundaries and a reliable way to repair its mistakes. Which brings us to the critical truth that really separates amateurs from true builders. Trust is greater than the demo. The demo is not the system. Honest monitoring and governance are what actually protect real people.
Part 6. The complete builder returning to the human.
So if the model isn't the ultimate goal, what is it? What are we actually trying to achieve after mastering all these technical layers?
We return to the human. The true hero of data science is not the model, it's the workflow. We start with a question, we gather evidence, we apply human judgment, we take action, and we create real impact. The model is simply one capable worker inside that broader workflow. This is what makes you the complete builder. Remember, a builder uses tools to support human accountability, not to replace it. You are using evidence to reduce uncertainty for real people making real decisions. So as we wrap up this explainer, we want to leave you with one final lingering thought.
What matters more? More tools or better judgment?